Now we are going to do the second question of M1 January 2021. The question is two particles P and Q have masses 2m and m respectively. There are two particles P and Q, they have the masses 2m and m. The particles are moving towards each other in opposite direction along the same straight line on a smooth horizontal plane. The particles collide directly. So let's draw the diagram first. The diagram is, let's suppose this is particle P and this is particle Q. And as per question, the particles are moving towards each other in opposite direction. Let's suppose this is the direction of P and this is the direction of Q. The particles collide directly. Immediately before the collision, the speed of P is 3u and the speed of Q is 2u. The mass of P is 2m, so I will write it 2m. The mass of Q is m, so it's m. And before the collision, the speed of P is 3u, so I will say the initial speed of P, which is 3u, initial speed. So I will say it's up because initial velocity we represent by u, so I will say up is equal to 3u. While the initial speed of q is 2u, so I will say it's uq, which is equal to 2u. The magnitude of impulse exerted on q by p in the collision is 5 mu. The magnitude of impulse exerted on q by p is given. Mean whatever impulse the p will exert on q, that impulse is given. What p will exert on q, it is given 5 mu. The magnitude of impulse is 5 mu. So find the speed of p immediately after the collision. So let's take I will say I'm taking the direction of the impulse positive in this direction. This is the positive direction of the impulse. If P exerts an impulse on Q, so as a result, as a reaction, Q will also exert an impulse on P, which will be equal in magnitude but opposite in direction. So then the magnitude of impulse on P by Q will be minus 5 mu. So we have to find the speed of P immediately after the collision. Let's suppose the final speed of the P after striking is Vp, and the speed of Q after collision, let's suppose, is Vq. So we have to find Vp. So to find Vp, I can use impulse. Right now we are having, as we have to find the speed of P, so I will take impulse on P by Q. Consider this one and then we will be able to find this one. So it is equal to, we know, minus 5 mu, because we took the positive direction of impulse as this direction, right direction. You can take the other direction also. It doesn't matter whatever direction you choose the positive, but according to that one you have to solve the question. So if I will use the formula of the impulse, we know the impulse is equal to mass of the particle into final velocity. As we are considering the impulse on P, I will say it IP. So it will be the mass of the P into final velocity of P minus initial velocity of P. So what is IP? It is minus 5 mu. That is equal to mp. The mass of P is 2m into final velocity of P that we have to find, Vp, minus initial velocity of P is 3u. I'll write it 3u. So from here it will become, let's simplify it now to get the value of Vp. That is going to be minus 5 mu equal to 2m Vp minus 6 mu. So that is going to be u equals to 2 mVp. So that is mu minus 5 mu plus 6 mu will be mu. equal to 2m Vp, the velocity of P after striking. So finally Vp will be equal to mu over 2m. M will cancel with m, we will have 1 over 2 u. It means that will be 1 over 2p after the collision. So our first part is done. We are done with the first part. The second part is saying find the speed of q immediately after the collision. Now there are two ways for that one. We can use a law of conservation of momentum, or even the same property that I use for the impulse, I can use for this also. Because we also have the magnitude of impulse exerted on q by p. So using that one, I can calculate the speed of q after the collision. So let's use that property. I will say impulse on q by p impulse on q by p, that already we know is equal to 5mu, because we have taken this direction of the positive direction. So if I will take iq, it will be equal to mass of q into final velocity of q minus initial velocity of q. So iq is 5mu, mq mass of q is given to us, it is m. So I will just write it m into velocity of q after impulse, after collision we have to find, minus uq. Initial velocity of q was given to u. So I will write it to u. And from here we can calculate easily vq. So 5 mu is equal to m vq minus 2 mu. Shift it to the other side. It will become 5 mu plus 2 mu equal to, yeah, sorry, here one more point you have to keep in mind. As the direction are opposite, it's given initially in the question, the directions are opposite, so we will take this one as negative. So it will be negative to u, because it is opposite direction of the direction of the p. So that is why I will take it negative to u. So it will become plus 2u, and here we will write as minus 2u. So this will be minus 2u equals to m vq. Finally, vq, the value of vq will become 3mu. I will have from here 3mu equal to mvq. So now vq will be 3mu over m. It will cancel, so we will have 3u. That is the final velocity of q. So this is the end of our second question of this paper.